An alternating current in amps is given by the equation I is equal to 0.02 cos of 4t plus 90 degrees, where the time is measured in seconds. Write down the values for the following quantities, including their units, and draw a sketch of one period of the current. Include the coordinates of maximum and minimum points and x-intercept. I will start with finding the quantities that I've been asked for. I'll start with the amplitude. The amplitude, as you can see from the equation, is 0.02 amps. The next quantity I look at is the phase angle. Phase angle, and it is equal to 90 degrees. I prefer to write degrees explicitly because it will be easier to handle the units once you do that. And I read that from what was given in the equation. That is a very important factor to pay attention, whether the phase angle is given in degrees or in radians, because that determines and affects the rest of your calculation. The next quantity I look at is the angular velocity. Here, I first pay attention that the phase angle is in degrees. That means that 4t is in degrees. Otherwise, how could you add 4t and 90 degrees? Only degrees could be added to degrees. And since the unit of t is seconds, therefore the unit of 4 appearing in the equation is degrees per second. So the angular velocity would be 4 degrees per second. The next quantity is the period. Since everything is in degrees, therefore the period is 360 degrees divided by the angular velocity, which is 4 degrees per second. That would be 90, and you can now simplify the units, 90 second, and that's no surprise because we know the period is measured in time, and second could be an appropriate unit. The next quantity that I will consider is the phase shift. It is defined as the negative of the phase angle, which is 90 degrees, divided by the angular velocity, which is 4 degrees per second, and this is equal to minus 22.5 seconds. Again, this is not of surprise because phase shift is measured in the units of time, and in this case in second. The frequency is the reciprocal of the period, which in this case is 90 seconds. That would be 1/90 hertz. Now we can sketch the current versus time. Here is the time axis with time measured in seconds, and here is the current axis with the current measured in amps. Okay, we start with the phase shift, and that is minus 22.5 seconds in the case of this problem. we add to the phase shift the period, which is 90 seconds in our example, and that leads to 67.5 seconds. 67.5 seconds. We need to find the midpoint of 67.5 and minus 22.5. The midpoint of 67.5 and minus 22.5, that is the midpoint of 45, which is 22.5 seconds, and that would be somewhere here, 22.5. Now the midpoint of minus 22.5 and 22.5, and that would be the center of the coordinate system. And next we need the midpoint of 22.5 and 67.5. That is a half of 22.5 plus 67.5, which is a half of 90, which is equal to 45 seconds. 45 seconds. The base function for cosine looks like this. Therefore, in our case, before that, let's also show the amplitude. On the y-axis, the amplitude is 0.02, 0.02, and minus 0.02. So we start to copy the base function. We start with this point, and then the function decreases to 0, 0, decreases to this point, it increases to 45 and 0, and then increases to 67.5 and 0.02. This would be the graph of the current for one of its periods. By copy and pasting this graph all along the x-axis, which in this case is the time, you can find a general graph, and then you can choose the graph for any period or any time interval that you're looking for. But at this stage, we have the graph for one period with all the important points of the graph shown on the graph.